it is addition, multiplication, and non-negative whole numbers. Okay, it can be anything. And this is one example of a polynomial. Okay, equation x square plus 2x minus 7, but it should be equal, right? X power 4 minus 7x cube. Okay, and x. Okay, so all these things clubs under a polynomial. So about mathematics, I'm just going to tell what all the MATLAB commands through which these expressions will be evaluated. Okay, that is what the topic of discussion is going to be. And the first is just running a polynomial evaluation. How do you evaluate a polynomial? A polynomial can be evaluated by using the function polyval. This is the advantage we do have is we are working on MATLAB. So hold on, students. Just one question for you all. I hope you all are working in MATLAB.
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Very good. That is with the MATLAB tool.
No, sir. I have been using Scilab, sir.
Other than Shaurya, anyone using Scilab? Yes.
Many of them, sir. Everybody is like really familiar with
I have started using MATLAB only, but I'm not like properly accustomed to MATLAB.
Okay. One. See, tomorrow's, not tomorrow, on the 4th day of the exam, okay, you can use a Scilab or you can use a MATLAB. But one big advantage of using not version of the commands, right? In Scilab, you have to figure out the syntax. Sometimes this if you are working on MATLAB, one thing I can trust you is it will be very easy for the exact students.
Yes, sir.
Yes. Yeah. I don't think MATLAB. So that is one big advantage. We have started working in MATLAB. So that is why I also try to get commands in MATLAB itself, so that you will come into the comfort zone, so that it will be very check the conversion syntax. Like we are studying in MATLAB, isn't it? Because initially it was the base. Much we started with Scilab, but now my suggestion would be predominantly you try to use that work pressure of converting the syntax to Scilab commands will okay. I'll just go back. Okay, so this is what.
Sir,
Yes.
and one more thing, sir.
Yes,
sir, I wanted to ask you if you some practice questions for MATLAB programming, like for similar programs.
Abin, I haven't touched the pattern point of view. What I told, I'll finish my class, then I'll come into the syllabus and pattern of the questions. That's you got it?
Oh, okay, sir.
Okay. So I'll finish this. Priority is we'll finish the syllabus, then I'll come to what has to be done for the exam.
Yes, sir.
Yeah, fine. Okay, so we have been checking out polynomials. The polynomial, the command is the general form of the polynomial command is it is t comma s. Okay, this is the general syntax which MATLAB do. C is okay. You have c comma s, where c is a vector whose elements are the coefficients of a polynomial. Descending order, you know what is a descending order, isn't it? Imagine there are powers of 3. It is x cubed x. So the c is the vector which works out in the descending order on power of variables, and value the polynomial is to be evaluated. Okay, so c indicates the power and s indicates, and the command for the polynomial is it is polyval c comma s. Now we'll see a program. Okay, just watch this question. The question is evaluate the value of the polynomial.
I usually don't keep my phone on the
Equation is y
nightstand.
plus 3s
Just
plus
happened to
4,
end
and
up
they've
there
also given the
tonight.
value of s in the question. Okay, s is 1 See, normally what you'll do is in mathematics, you'll go for the direct substitution of S. Imagine I want the value of Y. You will go for the direct substitution of S. You will tell me it is 2 into 1 or whatever. S is equal to 1 and S is equal to minus 3. But what we have to do, we have to work it out in MATLAB. Okay. So on the command is, val y comma s. Just watch this. There are two subclasses of this question. One is for S is equal to minus 3. That is being given in the question. Okay. And the values are 2, 3, 4, right? Because so it is in the form of matrix. It is 2, 3, 4. You institute this command. Value is equal to poly of y. All manually, the value will be 9 when S is equal to 1. And for the second part of the question, minus, you induce this command, and when you manually substitute, the value is going to be 13. But what you're going to do is, so this is one big advantage of MATLAB. So what you're cutting down is, you're cutting down the manual evaluation. You are making the tool to do everything, right? So this is the command for and the second one is to finding out the roots of the polynomial. Again, I'm telling you, you should be mathematics. Okay, if you have a knowledge about mathematics, this extension of MATLAB is to figure out the roots, right? So you all know, but you need to do it in a command point of view.
Keep my
So
phone on the nightstand.
or R is equal to roots P. Okay, so this command is used to find the is a row vector which contains the coefficients of the polynomial. Okay. Now let's see how this comes. Okay, I'm not explaining much of your mathematics. I'm just doing for your MATLAB commands. Okay, polynomial. This will be a question. A polynomial equation is being given. Okay, so what you have to do is you have to take the it is 1, isn't it? It is 1s square. It is understood. 1s square plus 3s plus 2. Okay. I will substitute the syntax. R is equal to root P. And what we do ultimate direct is and R2. And what you get is R1 is minus 1 and R2 is minus 2. It looks like a very simple program, but if you don't know the logic of mathematics of finding out the don't understand how it is. So again, I am telling you is you have to practice this maths to execute this MATLAB commands. Okay. So this is for finding the roots of the polynomial. Again, I want roots of the polynomial. This is for your practice. I get the question. You can practice this. Then you take the syntax, apply it in MATLAB and find out the output. Okay. This is the polynomial addition and subtraction. Okay, and the syntax is you all know addition is x minus y. Okay, so now we will see how it works with respect to MATLAB. Right? So the question is crystal clear in the question. By the question itself, it is clear. Like the other functions, one is here, one is not. But you should be perfect in writing it. Okay, you should be yes, plus 1. Just watch here. Initially, you have taken as 0, right? Because there is no value for s. S square it is 1. For 2s it is 2, and the last is 1. And similarly for s cube square, so it is 0. For s is 1. This is 5. So trust me, if you go to make a mistake, okay. So hope you understand. Would be practicing in maths and. MATLAB. Okay, so the instruction is C is equal to A for addition. So you get the resultant polynomial equation, isn't it? So it is 1s cube plus 1s square plus 3s plus. Like this, you can use your mathematical knowledge and just convert it into MATLAB. Okay, one more is for addition. The next one is for polynomial multiplication. Yes, here. Polynomial multiplication is it is CONB x comma y or x comma y. This is the syntax and instruction for polynomial multiplication. Okay. Then we have the vectors of the coefficients to be multiplied and z contains the coefficients of the list. Z will be the output, that is the coefficients of resultant polynomial, whereas CONB, this is the command for polynomial multiplication. So you have maths. Okay. So now I'll go into the direct example. Evaluate the product of two any given question. That is one is s plus 2, the other one is a square plus 4s plus 8. You have to break it up. So it is 1 and 2. Y is 0, s square is 1, 4s is 4. They are asking for multiplication, isn't it? So you know the syntax. It is z is equal to c, and you can cross check this. It multiplies and it displays the output. And when it displays the output, polynomial equation. It is x cube plus x square plus 16s plus 16. Okay. This is very important. Okay. If you don't know the command on the syntax, you will. For example, about the matrix multiplication. Okay, I have put up 2 questions. The next is okay. So now previously we have seen multiplication. Now we are moving into division, and R is equal to D con. Okay, so find the difference. You are able to see the division and the division. Where in this division you have 2 parts, isn't it? Normal division you have the dividend. So here z is the dividend, y is the divisor vector, x, and r will be the vector of reminders. Okay, if you are in division, you know divisor. You need one value for the quotient, you need one value for the remainder. Okay, like that you need parameters. So you are fixes all the parameters in this command. This is the command for polynomial division. Okay. Question. The question is divide the polynomial by set. Okay, they clearly mention in the question what you have to add or subtract will be clearly mentioned in the question. Only thing is it's a mathematical question. Okay, so the command is this. We have already seen. Yes.
No row in the following statement like 0, 1, 1, 4, 8, 8.
Which one?
So in the example 4.8, there is a right. So can you present the screen?
Okay. Which after 16 you are asking a 0. Yes, this part you are asking something.
Sorry. Yes.
This. What is this clearly? Why 0 is not there in the thing, isn't it?
Yes.
Coming up again.
Hello, sir.
Yes, Sandeep. Come again, Sandeep. Come again. I'll share. Yes, come again.
No. Whereas code like y equal to 148, we have given that for the s square, but we are not given for the.
See, okay. Why we are not considering for s cube? Why we are not taking?
Yes, sir.
That is the question, isn't it?
Yes, sir.
Okay. So the dividend and the divisor, when you are writing it, when the equation is being for general maths, how you do it in a general maths? You will put a 0. So you got your answer?
Yeah.
So this is not basic mathematics. So you ask me a question on mathematics, right? So I'm just dedicating MATLAB. You got something?
So, but how will it know that it is the S square?
No, it's been given in the question, isn't it? It's been clearly mentioned in the question, which is
S cube or S square.
No, this is the evaluation. See, you have been implementing matrix things, isn't it? All these things you have been doing with matrix. So how the plus signs are normal values of matrix? We have been studying in second unit, right? Yes or no? When a normal value is given and you're writing it in a matrix, so how can I understand whether the output matrix is the same thing? Okay, so it's a default which is an inbuilt function of a MATLAB. Okay, so that is what we are not just on the values. Okay, can I continue? Fine, students. Okay, so yeah, we have been saying about the division. So I have just said work out with this. So this is the syntax for the division command. Okay, again I've just routed. So it was a is equal to x square minus 1. Other one is s. You can try how the command is working out and how you are getting the outputs. Okay. Okay, all these things we have a polynomial equation, but if the roots are being given, right? So you're a bit about if the roots are being given, how to develop a polynomial equation, right? So as solution of polynomial equation, right? In the case the roots of the polynomial are given, corresponding polynomial can be obtained by using a command called as poly, right? You have a in MATLAB, like when the roots are given also, what you can do is you can just develop how it is possible is through this command which is called as x is equal to poly r. Okay, and it will return a row vector values whose elements are the coefficients of the polynomial. So once when these elements, what we can do is we can develop the polynomial. So that is why it is called as polynomial, right? And just watch this question. The question is the roots are given. Polynomial with root minus 1 comma minus 2. Okay, and once when you include this command, right, and output is, don't ask me how is this output. Okay, because I have told the command, right? I have told the command the roots, the equation polynomial is being developed. Okay, so I'm just giving you the value. When I give this, the command p is equal to poly r, the resultant output will be 1. Okay, and this 132, obviously, you know, this is going to be the polynomial equation with respect to this state as yes or 1x or whatever. Okay, so this is 1s square plus 3 to 0. Okay, so like this, you have one big facility in MATLAB. So automatically, what it will automatically develop the equations. Okay, so this is one big thing. And one more question, right? You can just check for real part and the imaginary part. Okay, so it has been this unchecked whether this thing is being getting derived. Okay, and now matrix. See, we have been studying about matrix so many times, right? From first year. How the characteristics polynomial of a matrix can be developed. Okay, so it's like in MATLAB, the characteristic equation of matrix can also be obtained. But how is you have poly of A? That's the syntax. But this A we are giving in a bracket, isn't it? So you know that is the A matrix whose characteristic equation is to be obtained. Okay, and P is the row vector. Poly is the command. So how what you do is you can characteristic polynomial trained. Okay, so this is one thing of matrix. Just watch this. Okay, not much clear. Question. Determine the characteristic equation of a matrix. Okay, so these values are given in the matrix. A is so right, and how this MATLAB will understand? You know, it will understand like this. Okay, you have to. What you have to do is you have to give the command. Okay, P is equal to poly A. So once when you give this, the value, the result obtained will be 1 minus 3 minus 2. Okay, so obviously of matrix and your output will be it is x square minus 3x minus 2 is equal to 0. Just saying with commands, they are not running anything. I'm just giving you the command. You just take the logic is being evaluated. Just apply this command syntax and see how this Okay, so this is about deriving matrix. I have kept one more question, and now an integration. Okay, so this is all again oriented with your mathematics. So isn't it? To evaluate the polynomial differentiation, that is dy dx is equal to poly dy. Okay, so er is used to compute the derivative of a polynomial. Okay, so this is given out the differentiation, right? This is your syntax, right? Where y what structure of the coefficients of the polynomial, right? And this dy by dx, I mean dy dx like iter of the derivative obtained. So this syntax is uniquely utilized for polynomial. So see the question: evaluate the derivative of the polynomial y is equal to plus 8x square plus 16. Okay, so there was one question, isn't it, sir? The value is missing. Just check out in this question. I think in this question you have presented s cube 4 is there, s square is there, but obviously x is missing, and we are giving the value of 16, right? So the thing is, the command is equal to. So once when you give this command, the resultant is it is 4, 12, 16, 0. You have how it is 4, 12, 16, 0, because once when you do a manual, right? So obviously it is dy by dx with respect to differentiation. It is selection as it is 0. So we are omitting it. We need not bother about this. Okay. So again, one more question about differentiation. You can check it out. You can run this and there is one more syntax for integration. Okay, so we have seen done the syntax for integration is poly int y comma k. Okay, or x is equal to poly int y comma k. Okay, so this poly int of a polynomial. This command is very important. Okay, without using, you are using some other and telling me so this is not working, it doesn't work, because this is a very specific command for MATLAB for polynomial. Okay, where y represents the vector coefficients of polynomial. Okay, this is the command. We'll see how this command works. Now what's this question? Okay, they'll be defining the question whether it is integration or differentiation. Integrate the polynomial y is equal to 4s cubed. Okay, so what you do is and take the constant of integration as 3. Okay, it is being clearly mentioned in the question has been as 3, right? So the syntax is x is equal to poly int y k, right? K is a scalar constant. You might ask the question, so what could be the constant? But the okay, so constant integration is taken as 3. So once the constant integration is taken as 3, this will be the evaluated for integration. Okay, again this max part comes. So when you integrate this, so what they mean to do is s power 4 plus 4s cubed plus 8s squared plus s plus 3. Here the value of constant of integration is 3. So they clearly they tell that so this is one thing about integration. The next one is I have just one example. Okay, so this is the one more example, just you can check it out. And the next the last, that's mostly the last thing, this it's called as a curve fitting. Polynomial curve fitting is known in terms of vectors x and y. A polynomial can be formed point. We will see the question how it works. So fit the polynomial curve fit axis is equal to polyfit x comma y comma k. Okay, where of the points. Okay, this x and y will be the vectors and k will be the order of polynomial. We need a very specific thing, order, isn't it? So this x and y will be the vectors, be the desired polynomial. And what is the job of this command? This command returns the coefficients of data in descending powers. A very important parameter. It always, what is the functions of kth order polynomial in descending powers of x. Okay, so these points. So once these points, you will understand why these commands are being worked in MATLAB. Polynomial, and just an example is being given. Okay, so find a polynomial of clearly given in the question. What should be your final output is, your final output should be in the form of x and the term. Okay, so this is for x, this is for y. This degree they are given, clearly mentioned in the question, it is of degree 2. So it is x comma y comma 2. Once command, you'll be deriving these values. So once when you derive these values, you know we have to form the polynomial is, it is 7.3 minus and so on. Okay, so this is the fitting. So we have developed an equation, that's what matters. Okay, so I think one more this about current and voltage, and in the question they have given, obviously they'll give work is 1, right? So it's like use the commands and fitting, right? And the last thing is evaluation of polynomials with I'm telling there is also matrix commands which can work with polynomial. So see a line. The polynomial can also be evaluated for a square matrix S. We're going to use this polynomial and we are going to evaluate a square matrix. In this, equal to S square plus 3S minus 7. Okay, this is your question, but we need to square. So how it will become? PS is equal to S square plus 3S minus 7L. The R matrix. Okay, where L is considered to be the identity square matrix, S is the square matrix. This L indicates the identity of the square matrix. Okay. Equal to poly BALN A comma S. This is for evaluating the matrix arguments, where this A indicates the row vector and this S, you know it. Okay, so now we'll see this problem. Just check this. Evaluating the matrix x square plus x plus 2, given that the square matrix is x is equal to 2, 4. Okay, so what is you have to evaluate this for A, for X. I'm telling you, you have to understand this. You have to just I'm just running through the slides. What you do in the tool, just understand how the commands are being written, because I've told the syntax and go a little bit with the commands, right? Because right now we are in 3rd unit and still little bit of literally I want you all to practice. Okay, so once when you use that's what use a matrix polynomial, that is the output is the mail. One more question is also being given. Okay, you can just give it on a try how it works. See, till now we have been seeing about polynomials, but what are the commands we have seen about poly VAL? This is for evaluating the polynomial, the general polynomial. Okay, what is being used for? It is used to compute the roots of the polynomial. And B, hope you remember, it is for the multiplication. Okay, it is convolution or polynomial. The next DCONV, the opposite. Okay, it is deconvolution or polynomial deconvolution. The next one is the command poly. What is the command is being used for? Polynomial. In the question, if they are given the roots and they are asking to get converted into a polynomial, this polyger. Okay, it differentiates a polynomial. This is used for differentiation. Polyint. This is for integration. Integrates a polynomial analytically to the given data. And polyval evaluates a polynomial with matrix argument. To speak polynomial topic, these are the different commands with which So I thought I'll just keep this syllabus 3 till this polynomial third unit. Okay, still little bit is there about, just I put the commands. Okay, and I'll just show you. I'm not going to ask any questions in this. Okay, linear algebra, and if you take linear algebra, again it is purely mathematics students about. Okay, and there are some functions. What are those functions? Is for evaluation, matrix decomposition, matrix operation, matrix structure, matrix properties, all these things comes under linear algebra. Okay, so we are not going to evaluate much. I'm just showing the commands for linear equation which is used in your MATLAB. I've taken from MathWorks, and the ML divide, it is for solving linear equations. The function is AX is equal, and R divide, solving of linear equations, XA is equal to B. So like that, each and every has a specific function, and you can make out the difference. The commands are in blue, which the execution is this. Okay, so this is little bit about linear equations. Don't worry, this is not, I'm just showing you what it is. Okay, and one more thing you'll have is matrix. See, what is this decomposition? See, whenever you use of steps, okay, but in MATLAB, what you have is you have some specific functions which is systems for solving linear systems. Okay, and that one specific decomposition. Okay, and they are given some things how to work on with. They are just in the description. You can read this. Okay, I want you to read this, but not for this time, but after. And they are given the syntax also for decomposition. Okay, imagine D of A, meaning is given here. It returns a decomposition of matrix A, and imagine DA is equal to D. What it does is it specifies the type of decomposition to perform for a triangular or whatever. More comments. The description is available over here. Okay, so you can just check out this. Okay. Yes. So till this, I thought of telling you today. Your syllabus will be till this. Okay, till this list of commands of polynomial, along with the second unit. So there was some representation, right? Slides of second unit, and I need to share it to you. So that will be done. To tell you is, yes, the pattern. The pattern is it is session. Okay. So in that pattern, 4 10 marks. Okay, 4 10-mark questions will be from your second polynomial, what we have seen, right? So 40 marks will be from the I'm going to share. The 40 marks is going to be fetched from the PPT. Okay, I don't want to keep any MCQs. Okay, this is not an MCQ kind of a subject. This is like analytical subject. One thing you're going to learn from the subject is working on the tool. Okay, working on the tool.